In this video, I'm going to be talking about my air compressor that I keep stored away in a sealed closet to reduce the noise. Let's jump right in. What you're looking at is a sealed enclosure in my shop where I keep my air compressor. The first thing I want to discuss is the situation when it comes to putting your compressor in an enclosure. The first and most obvious thing is it is not recommended because of airflow. These can get pretty hot, and they do, and you want to make sure there's a lot of air circulation so that they don't overheat. I have had several issues with this compressor overheating along the journey and have since resolved all of those issues and want to show you how I've done that. So if you look over here in the corner, and I will zoom in here, I have one bathroom fan that is about 6 inches away from the motor, and then I have another bathroom fan down there. These fans are both on this thermostat that is set to like 85 degrees. So when this room gets hot, and it does pretty quick, both of the fans kick on. Previously, I was running one fan, and I would be able to run the compressor a long time, and by a long time, I mean maybe an hour continuous, which is a little bit unusual, but usually it would be when I was using a DA sander, working on some sort of sheet metal project for an extended length of time. I would overheat the compressor, and it would trip the overheat switch, and I would have to wait for it to cool down. So using one fan, I was able to get about an hour. I put one in immediately. And then also I installed, you can see them down here. I'll get some better footage of them in a minute. But there are two exhaust ports going outside, because if you put fans that exhaust air, or intake air for that matter, but don't have exhaust, nothing's going to happen. So you want to make sure that there is flow since it's sealed. So basically I suck air in from those tubes, and then I exhaust air out from these exhaust fans. And I will show you how I have that arranged on the outside of the garage. Basically what it does is it takes a fair amount of the noise and it puts it outside. And I am in a neighborhood, but it puts it outside on the back of the house and really cuts down on the noise. When I added the second fan, I can basically use the compressor. I've used it up to 2 or 3 hours on a 90-degree day in this cabinet, and it hasn't overheated on me. Now I know that that's not recommended. Even if it doesn't overheat, doesn't mean it's running too hot, but I have it set up that way, and I want to share it with you guys so that way if you're thinking about this, you're aware of what works and what doesn't. And the way it's set up right now, it does work, and it doesn't overheat. So that's that. The other thing that I want to point out is majority of the air noise that you get from a compressor comes from the intake. So I have this intake actually routed outside as well, and I will show you on the outside what that looks like. But what this does is this takes the noise that you get from turning the compressor on from the intake, and it takes that noise and puts about 70% of it outside. So the intake is muffled, and then the sound of the compressor is muffled. It actually makes it really, really nice. You can have a conversation in here, no problem. And when the compressor kicks on, it doesn't even scare you half to death. It's very, very minimal. And it's really the best compromise I can think of, having a full size 60 gallon in your garage and hardly noticing it. The other thing I want to talk about that needs to be mentioned is the drain. So the problem with putting your compressor in an area you cannot get to is the compressor needs to be serviced. Mainly, it needs to be drained on a regular basis, ideally daily, or on a frequent basis to get all the moisture out. So there's two things that I'm doing to address that. One, and I will get some better footage of this compressor actually has, and if you see these hoses here, the copper hoses, they are not factory. I've added those. And they go to a radiator in the back that is made up of a B&M transmission cooler. So basically what it does is it is like a external cooler for the compressed air. So when the compressor compresses the air, it sends it through the cooler first and then sends it back into the tank. And you can look at other videos on YouTube. This works exceptionally well. It lowers the inlet temperature, or the difference between the inlet temperature and the outlet temperature of the cooler is like 50 to 70 degrees less. And that is a huge difference because it is the heat that causes that condensation and moisture in the tank. So that's the first thing. We want to mitigate any moisture going into the tank to even begin with. And then the second thing is when you do have moisture, you want to be able to drain it conveniently. So if you look back down here at my drain, I have it set up to where it can be drained externally. I have a bike hose or like a bike brake wire attached and made a custom bracket. So that way, external of the tank, I can pull, and I'll show you here on the wall here. I have made this. And basically what that does is that releases the moisture in the tank. The reason this is extremely important is because if it's not convenient, you're not going to do it. So I knew that if I close this in the container that it's in and put the bandsaw in front of it, I'm not going to open that to drain the tank, and therefore I'm going to shorten the life of my tank. Now, some of you are going to argue that I'm shortening the life by having it in a hot environment, and that is a fair point. But the goal here is just to try to take care of it as best as I can inside the container or inside the enclosure so I can get the best of all the worlds, really. So by doing something like that, it allows me to drain the tank externally and keep the door shut, and it's nice and easy. That's pretty much everything I want to talk about on the inside of the cabinet when it comes to keeping everything cool and well ventilated and quiet. Now I want to move on and talk about the air system in the shop as a whole and what I'm doing in general to really mitigate the moisture. All right, I just want to apologize up front. I really want to show you this, but this Lista cabinet is in the way and it's too heavy to move just for this, so we'll do the best we can. So if you look here, the air will come through the actual enclosure and it comes right into this manifold. Now you can jump online and research these. They're very common and they work very, very well. Basically, they can be made similar to the radiator on the inside. It's just 5, 6, 7, 8 tubes that are all looped together. And basically what it does is it allows the air to cool down. And typically you use bigger size pipes and smaller size pipes to slow down the velocity of the air. And what that does is that it lets the condensation collect at the bottom where you have 4 or 5 separate drains. So coming out of the compressor, what I do is I cool the air immediately. Then I put it into the tank. Then out of the tank, it comes over here and comes to my manifold. And the manifold has 1, 2, 3, 4, 5, 6 bars. And so once it gets to the 6th bar, it's pretty much moisture free. But at that point, it runs into that regulator that collects any moisture. And then at that point, it runs to the whole shop. And I can tell you from experience that when you go to drain this, there is absolutely no moisture that comes out of there ever. All right? And at that point, what it does is it goes to the rest of the shop. And it goes up the wall and it comes into these T-fittings. All right? Now, ideally, I know that you are supposed to do a leg on these T-fittings to reduce moisture. That is the right way to do it. I did not do it that way just because of the space and the time it takes. And I thought that I would have enough moisture solving capabilities with everything I was doing that I wouldn't need it. And that has been correct, but I just want to point that out because technically, ideally, you should have all of your airlines ran where they slope in one section mildly, and then they have a leg each time there's a drop. So that's just something to be aware of. So these airlines are run all across the shop, and then specifically for painting, which is more of a strenuous requirement on your air compressor, I have a even more further filtration setup. Once the air comes to this point, I go ahead and divide it into 2 sections. The first section is just a normal air section that has a regulator and a water drain, and I actually tee off of that and go outside to one of my Cox reels. I use that to fill up tires, and then the other comes over to this DeVilbiss filter. I have it divided off like this, and then I have a valve here for one main reason. I want to make sure that this filter is not receiving air most of the time. So I only turn air on to the filter when I'm painting, and what that does is that extends the life of this filter probably by about 500%, because it's only getting air about 10 to 20% of the time. And then this filter just filters any last contamination or air that gets to the point, and it just makes for a really clean experience spraying with the gun when I'm painting. And then just to give you an idea, I've had these filters on here for about 2 years, and I've never had to change it. And it gives you an indicator of blue, pink, white, and I can tell you immediately it goes pink pretty quick, but it's never gone from pink to white. So I've been able to have these on for quite a long period of time without it actually needing to be changed. So that's telling me that the system is fairly efficient before this point at getting rid of the moisture, which is great. The other thing that's really nice about this system compared to like a typical air dryer system, which you would find in a body shop or a shop that has a really high budget, is those systems require the purchase of a $1,500, $2,500, $3,500 air dryer that basically does the same thing as everything that I have set up does. And that's okay, but the main issue with doing something like that is you're relying on all of that cooling of the air to extract the moisture on one thing, the air dryer. And so because the air dryer is basically like a fridge with lines running through it, if that fails, everything kind of after that is going to have moisture in it. Whereas a system like this, it's probably about the same cost to set up by the time you build a manifold and cool the air at the, at the compressor. But once everything is set up, it's completely maintenance free and it's completely passive. You don't have an active like dryer that's plugged in, consuming energy, operating a fridge unit to cool the air. Everything is done passively, and it's really nice once you get it set up, because you just leave it that way and it's always going to work. It's never really going to fail. It just passively gets rid of the moisture. So I really like the system. It's given me excellent results for painting, and it keeps everything free of water for my tools. And as far as oil goes, what I do is I just typically oil at the tool. That way I can leave all the air lines free of oil for painting and just for general air spraying. And then other than that, everything has worked flawlessly. It is a little bit over-engineered, and I will admit that is the case, as with many things that I do. But the benefit is once you put the work and set it up, you just got clean, dry air. Everything's pretty easy, and you're going to have clean, dry air for a really long time. So I think this system works pretty effectively, and I'm really happy with the way it's set up.